Kia ora koutou, Reese from QuickSense here, and today we're looking at the angle between a line and a plane. Now, often with these kinds of questions, you're asked to do projections or find the shadow of things. So it often helps to think of this in terms of shadows. So this has a big cuboid, and it's asking us to write the projection of the line FB, which you can see I've already marked on there, onto the plane EFGH. So if I were to think of this as EFGH being the floor, what would the shadow be of the line FB onto the floor? Right? Well, we can see that B, the light would hit G, right? And so it would all move down here. If I'm looking above it and looking at that plane, then this becomes that line there. So how would I write the projection of FB onto the line EFGH? Well, I would write it FG. In this next question, we are given a 3D shape, in this case a square-based pyramid, and asked to find the angle between the line AE and the plane BCDE. Well, the plane is the square base, and the line is this line here. So what we're trying to find is the angle between in that point there. Okay, so what do we know about this? Well, we're going to have to break this down. Okay, and as we can see, we've actually got and I'll try and make this clear, a triangle. Right, so we've got a triangle. So let's draw this triangle. Beautiful. So 15 here, and we're looking for this one here. Right, we're looking for this angle. Right, I don't know what any of the other sides are, but actually I can use this other triangle in here to help me out. Right, because what I have, and let's draw this triangle as well. Let's do this one in black. Right, so this triangle is that one there. So the outside is 16, and then these are both the same. So let's just call them x. Right, they equal the same thing. And what do I know? Well, because of Pythagoras' theorem, I know that the hypotenuse, which is 16 squared, is equal to the square of the other two sides. So x squared plus x squared, which simplifies to 2 lots of x squared. So what's 16 squared? Well, 16 squared, 16 times 16, that's equal to 256, right? And I'm going to divide both sides by 2. So 256 divided by 2 is 128, and that's equal to x squared. So x squared, well, if I square root both sides, well, what's the square root of that? It's x equal to 11.31. Okay, and well, what does that mean? Well, that means that I now have this distance here. Okay, so this distance is 11.31. With these two, I'll just move this out the way. With these two figures here, I can use a little bit of trigonometry. And the trigonometric ratio I'm going to look at, well, I have the opposite side, right? The side opposite my angle. So O is equal to 15. And I have the side next to, the adjacent side, right? The one that's touching. The adjacent is equal to 11.31. The trigonometric ratio that uses opposite and adjacent is TOA. What am I trying to find? Well, I'm trying to find the angle. Okay, let's use a different color. I'm trying to find the angle here. So if I cover up the T, I'm left with O over A. Okay, so let's do a little bit of trigonometry. Well, tan theta is equal to, I'm going to substitute some figures in, 15 over 11.31. Just to be clear, we've got 15 here, 15 here, it's the opposite, over the adjacent. I'm going to try and find this angle. So I'm going to keep that as it is, and I'm going to do the opposite of tan, which is tan inverse 15 11.31. Okay, now we're going to have to use the calculator here. So 15 over 11.31. And then we're going to tan inverse this figure here, which is 52.98. And we're going to leave it as is. So what's the angle? Well, the angle between here is 52.98 degrees.